you noticed, we did 5.3, and then we did 5.5, and then we did 5.6. Today we're doing 5.4. Here's why we did it out of order. In these, we learned what proved two triangles were congruent. There were 5 theorems. Can someone name one of them with a raised hand? Landon? We got side, angle, side. Natalie? Side. You got it, Avery? Angle, side. In the back. Amelia? Hypotenuse leg. And then there was the last one. You got this. Angle, side, angle. Perfect. So I don't know why your book does this, but they put 5.4 in like the dead center, and it has nothing to do with the other lessons. So we did all of these. We're going to review all of them tomorrow. We're also going to review this lesson. But once you learn it, you've learned this entire chapter. Your last test for the entire quarter is next Wednesday. So that's it. Your projects are in, your test is in. The only big thing is next week's test, and then obviously the midterm, which is where 2 test grades. Okay? So keep that in mind. If you have not made up a test or a quiz, you need to make it up either today or tomorrow. Those are the last 2 days, so I can get those grades in. Okay? So we're going to talk about 5.4, equilateral and isosceles triangles. So we'll start with the fill in the blanks at the top. Is this a question that is pertaining to the whole class?
Well, let's just I guess maybe let's just say I did bad on the project. Would that midterm bring it up? Like, would that make up for it? If I did good on the midterm.
Doing bad on the project?
Like if I just did bad on the project.
It's a test grade, so the midterm is also a test grade. It would change that score, yes. Affected? Okay, using the base angles theorem, so you have to fill in the blank. A triangle is isosceles when it has at least 2 congruent sides. So your first blank would be that it has at least 2 congruent sides. An isosceles triangle has at least 2 congruent sides. So when it says at least, does that mean it can have less than 2 congruent sides? No. Does it mean it can have more than 2 congruent sides? Yes. So is an equilateral triangle also isosceles? It is, because it has at least 2 congruent sides, so there's 3. Your next blank, well, we'll get to that. When an isosceles triangle has exactly 2 congruent sides, these sides are called the legs. So go ahead and write in the legs on your picture. So the 2 congruent sides are called the legs. So a leg and a leg. The angle formed by the legs is called the vertex angle. So the angle formed by the legs is called the vertex angle. It's also a blank. So you'll write it up here, and it's also a blank. So what that means is where the 2 legs come together, this is what we call the vertex angle. Okay? The third side, the last side, is called the base of the isosceles triangle. There's only one base. There's 2 legs, but one base. And then the angles adjacent to the base are called base angles. So you should have all blanks filled in by now. And then, what an interesting highlighter. Interesting. All the blanks should be filled in, and then your picture should look like mine. The reason this matters is later on it's going to give you like a word problem and describe your vertex angle or your base angles, and you'll have to find other things based on that. So, earlier in the year, not even earlier in the year, earlier in the chapter, we said when you have 3 congruent sides, what did that mean for your angles? You have 3 congruent angles. So what if you have 2 congruent sides? 2 congruent angles. You just haven't learned where they are yet. That's the purpose of today, to figure out where those congruent angles are going to be. So you have this in the middle of your page. If 2 sides of a triangle are congruent, then the angles opposite them are congruent. So here's what you're going to do with your highlighter. we have AB marked congruent. Okay. What angle is directly across from AB? What angle is directly across from AB? C. Angle C. So you're going to highlight this angle is across from AB. We'll do the same thing with the other. We have another congruent side. What angle is across from side AC? Angle B. So what you're going to write in, you have a box here, don't you? A blank box. You're going to write if AB is congruent to AC. So if side AB is congruent to side AC. We're down here. We highlighted these. Yeah. If side AB is congruent to side AC, then, okay, we just wrote them. What side was across from AB? So what angle was across from AB? C. So then angle C will be congruent to angle B. So because these two sides are congruent, these two angles will be congruent. Okay? And then the opposite will be true as well. Okay, so in the second one, what's marked congruent this time?
B and C.
Yeah, angles B and angle C. So the same thing will be true. The side across from angle B will be marked congruent. So what side is across from angle B? AC. So AC will be marked congruent. Angle C is marked congruent. So what side is across from angle C?
AB.
AB. So then you fill in the blank. If angle B is congruent to angle C, then side, so what corresponded with B again?
AC.
So then AC will be congruent to, AB. So if angle B is congruent to angle C, then side AC is congruent to side BC. Here's what I'm going to have you write, and then you're going to highlight it. Angles are congruent to angles, and sides are congruent to sides. So angles are congruent to angles, and then sides are congruent to sides. Angles are congruent to angles, and sides are congruent to sides. So here's what that means. If AB, let's say, was 4. Okay, can we say it's 4? What else would be 4? AC. The angles would not be 4. Let's pick a number for the angles to be. An angle. 2 degrees looks like this. So let's pick up an appropriate angle. 35 is fine. So if angle B is 35, what would the measure of angle C be? 35. Okay, so sides are congruent to sides, angles are congruent to angles. The purpose of this theorem is to find where the congruent sides or the congruent angles are. All right, so let's do our 2 examples. It says name 2 congruent angles in our example 1. So we use the congruent sides to find which angles will be congruent. So what angle is directly across from DE? Angle F. So angle F is going to be a congruent angle. The other side mentioned is DF. is marked congruent. So what side or what angle is across from DF? Angle E. That's it. This is a literal question on your quiz. The letters will change, and the triangle might turn. But same thing. It'll ask, name two congruent angles. The second, they gave you the reverse. They gave you two congruent angles. We need to find which sides will be congruent. So let's do A first. What side will be across from angle A? BC. So BC will be marked congruent. My other angle marked congruent is B. So what side is across from B?
AC.
AC. So BC will be congruent to AC. That's it. Whenever you're ready, we can flip. So Anthony, you look ready, so we can flip. These are the types of problems we'll be talking about. Find the value of x. So in number 1, is x a side or an angle? It's an angle. So we need to make decisions about our angles. Do we know the measure of all three angles? No, but we definitely could. We know this is an isosceles triangle, right? So if two sides are congruent, two angles will be congruent, right? So let's figure out what two angles will be congruent. So we have x, it will be one of them, because it's across from this congruent side, so it will be one of our congruent angles. What will the other angle be congruent? Will it be 130 or will it be the blank? Which one?
Blank.
The blank. So the blank angle is across from our other congruent side. So what will the measure of the blank angle be? X. It is only x because it is going to be congruent to this angle. Now we have three angles in a triangle, right? We got x, we got 130, we have x. What do we know about the three angles in a triangle? They add up to 180. So that's what we do. So we're going to say x plus 130 equals 180. Combine like terms, we get 2x plus 130 equals 180. What do I do next? Subtract 130. So 2x equals 50, and then x equals 25. The second one, is x an angle or a side? It's a side. It doesn't look like we have any information about our sides, but we do have information about our angles. We know we have two congruent angles, so then what do we know about our sides? We'll have two congruent sides, so this side will be congruent to this side. So what will 3 times x plus 2 equal? 24. So 3 times x plus 2 equals, equals 24. So next we will distribute. So we'll have 3x. 3 times 2 is 6. Next we're going to subtract. What is 24 minus 6? 18. So then x equals 6. Alright, so we're going to move on to equiangular triangles. You actually already know this. You have a really big blank right here. If a triangle is equilateral, then it is also equiangular. So that's that first blank. If a triangle is equilateral, then it is also equiangular. So if a triangle is equilateral, then it is also equiangular. You'd write the whole sentence, not just the word equiangular, because that doesn't mean anything. So then you can guess what the other one says. If a triangle is equiangular, then it is equilateral. And then we'll talk about it. So if it's equilateral, it's equiangular. If it's equiangular, then it is equilateral. So this is where I have to remind people the most that angles will be congruent to angles and sides will be congruent to sides. So if it's equiangular, all of the angles are the same measure. So what will the measure of each and every angle be? Yep, so what will the measure of each angle be? It'll be the same. So how do you make 180 into 3 even angles? Divide by 3. So what will the measure of each angle be? 60, 60, 60. That will not change. The angles in an equiangular triangle will always be 60. That's the only way to add them up and set them equal to 180. The sides, however, will not be 60. The sides will be whatever it says. Pick a number, any number. 23, she says. So if AC's length is 23, all of the rest of the sides would be 23. Okay, so the angles will always be 60, the sides will change. Okay? So we're going to use this in this following problem. I would probably highlight it or put a star next to it. You're going to see it on the quiz, you're going to see it on the test, you're going to see it on the exam. It's literally the same problem, your numbers are going to change. But you're going to see the same thing over and over again. We have 2 triangles here, right? That share a wall. We're going to talk about the first triangle, this left triangle. What kind of triangle do we know that it is? It's equiangular, which means it is equilateral. So I'm going to go ahead and write in that information. So because it was equiangular, it is also equilateral, so I put dashes. This section is going to be really hard for you if you don't pay attention to these problems. I'm just letting you know. Because it's a lot of puzzling, it's a lot of figuring out. Is y an angle or a side? It's a side, so we know all the sides are the same. So what will y equal? 4. So we got that one going for us. Y equals 4. I'm actually going to label all the sides as 4. It's going to help me in the next part of the problem. My next triangle, what kind do we have over here? It's isosceles. So we have 2 congruent sides, which means we have 2 congruent angles, right? Or sorry, vice versa. We have 2 congruent angles, which means we have 2 congruent sides. So what 2 sides will be congruent? 4 and x plus 1. So what will x plus 1 equal? 4. So then x equals 3. Go ahead and flip. They do get harder. These are the last 2 we do together. Find the values of x and y. Do we want to find x or y first? It's up to you. Sure, we can find x. Is x a side or an angle? It's an angle. So we only want to look inside of the triangle at the angles. So we're going to ignore everything on the outside of the triangle. Okay? What kind of triangle do we have? Equilateral, equiangular. So go ahead and mark all of the angles as 60. 60, 60. And even this angle is 60. We're trying to find the measure of angle x. So will x be more than 60 or less than 60? Definitely less than 60. You can find x 2 ways. You want to think of these, again, like a puzzle. There's many ways to come to the same answer. This is a triangle, correct? We already have x. We have 60. We don't know the measure of this angle, but we can know the measure of this angle. What relationship does it have with the angle right next door? They share a wall. They also make a straight angle. So that's a linear pair right here. So if you already have 80 degrees of the linear pair, how would you find the remaining of the linear pair? Subtract from 180. So we know this angle is 100. We know this angle is x. Sorry, 60. We know this angle is x. So we have 3 angles in a triangle, right? How can we find the measure of x? Add and subtract from 180. So 100 plus 60 is obviously 160. 180 minus 160 means that x has to equal 20. There was a second way to find this. This is the way that I did it. So any way is really fine. We have these 2 angles, right? 80 and 60. What's 80 plus 60? 140. So what's left for this angle? 40. You know the angle in the corner. The whole angle is 60. So if this piece was 40, this piece has to be 20. So either way you had done it, you would have still gotten 20. Have we answered the question completely?
No.
No, we got to find y. Is y a side or an angle? It's a side. So I'm going to erase all on the outside. What's the length of each side? 46. So this side is also 46. So that means this entire side is 46. How much of the 46 is already shown? 16. So what do I do to find what remains? Subtract. So what is 46 minus 16? 30. Good. The last one we do together, we could find y first. Is y an angle or a side? It's a side. What kind of triangle do we have here? Equilateral. So all the sides are the same, right? So I'm going to label them all y, 5y, because they are all 5y. What kind of triangle do I have right next to it? Isosceles. And I know that I have these 2 sides being congruent, right? So what will the length of this side be? 20. So 5y equals 20. So then y equals 4. So I take care of y. Let's find x. Is x a side or an angle? It's an angle. So I'm going to... So 20 has nothing to do with what we're doing right now, because 20 is a side, and we're talking about angles. We know that x is inside of an isosceles triangle, right? So that means 2 sides are congruent, which means 2 angles are congruent. So what 2 angles will be congruent? This x will be congruent, right? Because it's across from one of my congruent sides. And then this blank corner will also be x. Because these 2 angles are congruent. They're the same measure. So if this one is x, this one is also x. So all that remains is finding this obtuse angle. It will not be x. It is, however, a linear pair with this angle. Do we know the measure of the left portion?
Yes.
Yes, what is it? 60. Why do we know it was 60? It's an equiangular triangle, so all these were 60. So we have 60 degrees of a linear pair. So how much will this portion be? 120. Now we have 3 angles inside of a triangle. So we're going to add them up. And what will they equal? 180. So we're going to say 120 plus x equals 180. Combine like terms. subtract 120. So 2x equals, what is that, 60. So then x equals 30. From here, you're going to take out a sheet of paper. This is the labeling of the assignment. You're going to take out your textbook, go to page 256. 256. Anybody else need to sign out and grab a textbook? So you're going to write down the assignment, and then you're going to copy this piece. We're going to go over it together. So make sure you copy it down and then draw the picture, and then you're going to write these sentences so we can fill them in together. So our first, we said angle D and angle A. We'll do the second. It says we have AB marked congruent, and then also, what's the other side marked congruent? Yeah, EB. So again, you want to close it like a triangle. What angle will be congruent because AB was marked congruent? It will be E, but we're not going to call it E. Yeah, so why can't we call it angle E?
Because angle is...
Yeah, there's like 3 angles there. There's a lot of angles there. So we're going to name it. Whenever you can't name it with 1 letter, you name it with 3. So what 3 letters will we use to name this angle? AEB. Good. All right, and then for the second, what angle will be congruent because EB was marked congruent? So you want to be looking inside of this triangle. It'd be A. So here I could say angle A because angle A, there's only one angle. That's it. So again, it was this one because this angle is directly across from EB. The next two, we are given angles instead. So we need to find what sides will be congruent. So we have angle D congruent, and then what else do we have? Yeah, we have CED also marked congruent. All right, so what side is across from angle D? EC. And then what side is across from our other angle?
CD.
Yeah, CD. All right, last one we have EBC, right? EBC, which is this bottom left corner, EBC. Then it says ECB. Right? Did I do that right? ECB, yeah. So, what side is across from EBC? EC. And then what side is across from ECB? EB. Good. No, that's fine. All right, so you're going to continue. There's, I don't even know how many left. There were 11 total, so probably not that many left. So go ahead and finish the assignment. Make sure you draw diagrams. I'll walk around in 5 minutes to check your progress.